Sunil Munot, and I am from DIY team number 3. And me, along with my other 3 friends, Anurag, Subhash, and Vikas, have made the heart rate and oxygen saturation level measurement sensor for a group project of our DIY assignment. And I can show you what we have done exactly in this project with the help of this slides. So the basically objective and the scope is to find an alternative for the heart rate sensors which are existing but have very high cost, and hence thereby they are not affordable. So we try to make a device which is really of very low cost, and thereby using some good materials in it, like using best quality components, we try to make it good. And the schematic is we have shown it on the next page, because and we have made it in the website called circuito.io, because it is not possible to make in an Tinkercad. So this is a model, and in this model all the components are named accordingly, like we have used Arduino Nano V3 buzzer, Adafruit OLED screen, MX30105 heart rate sensor which actually measure the heartbeat and oxygen saturation level, then LEDs and resistors. And there are some suggestions like to replace Arduino with Nano V3 so as to make it good alternative in the terms of size as well as weight. And also to do the calibration, we have tried to make it in such a way that it can take an average value, and we can take only that values when the reading is stable. So the components are Arduino Nano V3, MX0102 heart rate sensor, Adafruit OLED screen, buzzers, LEDs, jumping wires, and breadboards. And the price of all these components are given here, and approximate value of our project is about 2,200 rupees. So we try to make it really cheap. And this is the function of MX30102 heart rate sensor, means how actually it is going to measure the heart rate and oxygen saturation level. Basically here it is given that there are different pins which are included, and here actual function is given, like it contains photodetector and red and IR LEDs, and these LEDs contains different wavelengths like 660 and 880, and by knowing those wavelengths it is actually calculating the value. Like for a heart rate measurement, it is given here that the blood has characteristic to absorb IR light. So by using that we are measuring heart rate. And for the pulse oximetry, it is based on the principle that the red light and IR light absorb the light which the blood absorbs. It will vary depending upon the amount of oxygen. So by calculating how much amount of light is absorbed, we are calculating the oxygen. And these are the tests and the analysis which we have done from our project. Basically we have done 3 tests, and here the reading of the test are given, and in the first column it is a pulse rate, and these are the readings which we got from our project, and these are actual reading which we got from smartwatches. Similar for the oxygen saturation level, and here we are calculated the error, and for the pulse rate it is coming 2.23%, and for oxygen saturation it is coming 1.02%. So the errors are so much small that we can say that we are mostly successful in calibrating our device, and thereby to make it exactly helpful. And here some information is given, like for normal human for normal person, the pulse rate is about 70 to 100 beats per minute, and oxygen saturation level is about 95%. And what we have achieved is the first objective is to make it cheaper. We have achieved that, and the second objective is to make it second objective is we have tried that to make it with the help of certain LEDs and buzzers. We try that it can give the signal when the values are when the value exceeds, but we are not able to successful that, because our breadboard is destroyed at last 2 days, and thereby it becomes faulty, and so we are not able to completely do that. So we haven't done that part. And after that what further can we do, like in this device we can add some more sensors like temperature and humidity sensors, biosensors which detect the brain waves, so that it can be make a complete device which is diagnostic our whole body. And also you can use IoT so that it can give us all the information to our mobile.
This is the Arduino code for our project, and we have used the Arduino IDE for creating, compiling and uploading the code to the Arduino. In this code, I have first include certain required libraries like MAX30100 pulse oximeter.h for reading the data from the sensor, and Adafruit.gfx.h for displaying the reading of the ppm and the SpO2 level which we get from the sensor on the OLED screen. Then I define the screen width and height as 128 and 32 respectively. Initially, when we do not put finger on the sensor, then the OLED screen will display initially a message pulse oximeter, and after 2 seconds it will display message put the finger on the sensor. And when we put the finger on the sensor, then to record the values of BPM and SpO2 from the sensor, I declare two variables into BPM and the SpO2, and the POX.getHeartRate and the POX.SpO2 are the two functions which will assign their values of BPM and the SpO2 to the variables BPM and the SpO2 for displaying it on the OLED screen. And the serial.println BPM and serial.println SpO2 will display the values of BPM and the SpO2 on the OLED screen. And by using these functions POX.getHeartRate and POX.getSpO2 in the loop, then we get updated values of BPM and the SpO2 values from the sensor, and then the average of these values are taken for more accuracy.
So this is our setup for the DIY assignment. For this assignment, we have created a DIY pulse oximeter which will be used to measure the pulse rate and oxygen saturation level of the body. For this project, we have used an Arduino Nano board, a MAX30102 sensor, and a 0.96 inch screen. We have connected the Arduino Nano board to the laptop using a USB cable for uploading the code and as power supply. The code is already uploaded in the board, so now I will connect it. It says place your finger. Now it will take readings for a few seconds, and once the readings get stable, those will be the final readings. As we can see now that the values have become static, so these are my final readings. Here I am measuring the oxygen saturation level using this smartwatch. So this is the final reading for the oxygen saturation level. Here I am measuring the heart rate through this smartwatch. So this is the final reading of heart rate from this.
Hello everyone, I am Subhash. My roll number is 21CS30022, and my contribution for this project is making PPT for first week, and I have done the final report for the submission, and I have also done the schematic view of the project. Here is my first PPT, and this is the final report.